Hello folks, we come to the part 3 of the miscellaneous exercise, and let's continue with the problems that we were doing. The 8th problem, it says that tan inverse of 1 by 5 plus tan inverse of 1 by 7 plus tan inverse of 1 by 3 plus tan inverse of 1 by 8 equal to pi by 4. You have to show it. So what we are going to do is, broadly we are going to use the formula tan inverse of a plus tan inverse of b is equal to tan inverse of a plus b by 1 minus ab. That formula broadly we are going to use by clubbing suitable terms together. So what we will do is, first we will club these two, lowest and highest together, and the middle two terms together, and let's see what happens. Consider the LHS, and here first we are clubbing tan inverse of 1 by 5 plus tan inverse of 1 by 7. We are clubbing, and we are also clubbing tan inverse of 1 by 3 plus tan inverse of 1 by 8. And we are applying that formula tan inverse of a plus tan inverse of b, and let's see how it is coming. Tan inverse of a plus tan inverse of b. By application of that formula, we are getting over here tan inverse of 1 by 5 plus 1 by 7 by 1 minus 1 by 5 into 1 by 7. This is going to be tan inverse of 1 by 3 plus 1 by 8 by 1 by into 1 by 8. Now let's see how this is coming. Tan inverse of, we'll have to equalize, into 7 into 5. So this will come to 7 plus 5 by 7 into 5 when we equalize. And this is going to be 5 into 7, denominator also 5 into 7, so that it gets equalized. Minus 1 by 5 into 7. Here tan inverse. Now again equalize. This will multiply by 8. This will multiply by 3. And here we'll multiply by 3 into 8, both numerator and denominator. So it's 8 plus 3 by 8 into 3, and 3 into 8 minus 1 by 3 into 8. So this can cancel, and we have tan inverse of 12 by 35 minus 1, 34. Tan inverse of 11, 24 minus 1, 23. Right, this can be simplified. 2 6s are 2 17s are. Again you can apply tan inverse of a plus tan inverse of b. So it will be tan inverse of, and we write there, let's check, tan inverse of 6 by 17 plus 11 by 23 whole upon 1 minus 6 by 17 into 11 by 23. It's not an easy calculation, lots of work is there. So let's get back doing the work. This is tan inverse of, we are having it simplified. Multiply this by 23 both in the numerator and denominator. Multiply by 17 both in the numerator and denominator. 17 into 23 both in the numerator and denominator. So here we have 6 into 23 plus 11 into 17 by 23 into 17 whole by 23 into 17 minus 6 into 11 by 23 into 17. Only easy calculation is 6 into 11. All the others is calling out for quite a lot of work. So let's gradually do it and find out what the answers are. Tan inverse of 23 into 6. 6 3s are 18, 6 2s are 12, 13, 138 plus 11 into 17, 17 into 11, 7s are 77, 11 plus 7, it is 18. So 187. Denominator 23 into 17. 7 3s are 21, 14, 16, 23. 9. 391. Minus 66. So let's have that. 138 plus 187. 15. 8 and 3, 11 and 1, 12. 325. And 391 minus 66. 11 minus 6, 5 to 325. Both is coming out as 325. So this is tan inverse of 325 by 325, which is tan inverse of 1, and we all know that tan inverse of 1 is pi by 4. That is RHS. Hence proved. right? Tan inverse of 1, we all know it's pi by 4, it's tan 45, which comes to 1, and that's how we have tan inverse of 1 as pi by 4. Tan inverse of 1 is pi by 4, and that's how we have done with this. So that's about it. Then we come to the next one. You have to prove that tan inverse of root x is half cos of 1 minus x by 1 plus x. Alright, let's assume the left hand side as theta, okay, and let's see if it's going to work. So before we start working, let tan inverse of root x be equal to theta. It will mean that root x is tan theta, or x square both sides is tan square theta. Okay, now consider the RHS. Okay, what will happen? Half times cos 1 minus tan squared theta by 1 plus tan squared theta. X is not so convenient, so we have switched to theta and we are working in theta. Now what is the advantage? 1 minus tan squared theta by 1 plus tan squared theta is cos 2 theta. So this is basically should be cos inverse. I'll just repeat that question. Yeah, cos inverse. So cos 2 theta. So because of the domain and all that, cos inverse of cos, it's going to work out as half times 2 theta. So that will get theta, and that is exactly our RHS. Tan inverse of root x, that is equal to tan inverse of root x. Theta we know is tan inverse of root x, and that is our RHS. Hence, good. Okay, so an intelligent substitution is what is required over there. So that's about that. We are coming to the 10th question. It's a famous question. That strategy keeps repeating in the derivatives, integration, differential equations, everywhere. So it's a strategy. It's more than the technique, more than the problem. It's a strategy and technique that you have to have in mind. So let's consider. We'll not go into the problem. Let's consider those terms individually. Try to understand it, and then we'll get inside the given expression. Consider 1 plus sin x. We can call this as 1, can be called as cos squared x by 2 plus sin squared x by 2. We all know by identity. And the sin x, we can call it as 2 sin x by 2 cos x by 2. Generally we call sin 2x as 2 sin x cos x, but when we go to the half angle, we call it like this. What is the advantage? This can be written as cos x by 2 plus sin x by 2 the whole square. So basically this can be written like this. Similarly, 1 minus sin x will become cos x by 2 minus sin x by 2 whole square. Therefore, what will be our given? Therefore, given is cos inverse of, because there is a root, so this will become just cos x by 2 plus sin x by 2, right? Because it's root. When you have the root, then the square will go off and it will remain as base 1. And this will be cos x by 2 minus sin x by 2. Here, cos x by 2 plus sin x by 2 minus cos x by 2 plus sin x by 2. So what will happen? Sin x by 2 cancel, cos x by 2 cancel. Cos inverse of 2 cos x by 2, 2 sin x by 2, right? 2 cancel. I should check whether it is not cos, it's cot. Yeah, so all this is cot. Cot inverse of cot x by 2, which we all know is x by 2. They have given us a domain, and therefore we can check. Okay, the domain is given in each problem, so we can check, and it comfortably lies in the domain. That is why this is possible. And this is exactly our RHS. No, it's not given, no, so we should take the LHS. Therefore, LHS. Henceforth. That's all about this video. We have still more problems left, and that we'll be taking it up in the next video. Thank you.